All right, so today we're going to be working on solving two-step and multi-step inequalities and some word problems. You're going to need your inequalities notes, and here we go. Line down our inequality sign, cover up the variable term. We're going to add the 4, the constant, to both sides. So 5x comes down, our additive inverses cancel out, our inequality symbol stays on the line. 11 plus 4 is 15. We'll divide both sides by the coefficient of 5. X is greater than or equal to the quotient of 15 and 5, which is 3. We'll translate this. X is greater than or equal to 3. Is 3 part of the solution set? It is, because of that equals 2. So are we going to have an open circle on 3 or a closed circle on 3? A closed circle. And the values that are greater are to the right on our number line. Let's try again. Line down our inequality sign. Cover up our variable term. When we cover up the variable term, we're talking about the entire term, not just the variable itself, but the entire term, including the denominator. So we'll get rid of the constant by using inverse operations. Bring down our variable term. Our additive inverses cancel out. 13 minus 4 is 9. Now what's happening between the x and the -3? Division. So the inverse of division is multiplication. What do we want to multiply by? -3/1. And remember, when we multiply or divide by a negative, what happens to the inequality symbol? It reverses, exactly. So our -3's cancel out, leaving us with x. We've reversed our inequality sign. 9 times -3 is -27. So here is our solution. Let's translate that. X is greater than -27. Is -27 part of our solution set? It's not, right? -27 would not make this statement true. It would stay false because -27 is not greater than -27. So I'm going to scale my work here, maybe go by 5s. And since -27 is between -25 and -30, I'll put it in there. I will label it as -27. We'll put our open circle and shade the values that are part of the solution set that are greater than -27. What do you think the first step is on example C after putting the line down your inequality sign? Good. We do. We need to distribute. So we have -7 times x, which is -7x. -7 times -3 is -21. Our constant comes down on the other side. Cover up the variable term. We're going to add that 21 to both sides. 28 and 21 is 49. You finish out this problem. What's the solution? Good job. We're going to divide both sides by -7. Do we need to flip the inequality symbol here? We do, because we divided by a negative. Very good. So we have x is greater than -7. Is -7 part of the solution set? It's not. So we need an open circle here on -7. I'm going to go ahead and number my number line. And the values are greater than -7 since we've reversed our inequality symbol. So we'll shade to the right. On our last example on two-step inequalities, this is actually multi-step. So before we use inverse operations to solve this one, we need to simplify and combine like terms on one side of the inequality sign first. So we have constants 4 and -7. We're going to simplify that up first so it makes all the work moving forward a little bit more simple. Cover up the variable term. Use inverse operations to get rid of the constant. Remember, this is 3 wholes, so when we line it up and we are combining it with our 3500ths, the 3 should be in the ones place. So our additive inverses cancel out. Since these are both positive, we're going to add, keep the sign. -5/10 divided by x, sorry, -5/10 times x, we need to divide by -5/10 on both sides. Do we need to flip the inequality sign? We do because we're dividing a negative. So we have x, and now we need to do a little bit of decimal work, times 10 to move that decimal one place to the right, times 10 again. So we have our new dividend as 33 5/10, and our new divisor as 5. So we have to do a little bit of division, 5 into 33 5/10. Decimal comes straight up into the quotient. We're going to do a little bit of long division. And I know you are super happy with this answer. -6 7/10. Does that put a smile on your face? 6, 7. So when we graph this, I'm going to use this line here as my line. We have a decimal this time. So remember, we need to put the numbers on the number line that go out to that value so we can represent at least what 2 whole numbers it goes between. And since -6 7/10 is between -6 and -7, we're going to plot it, open circle because it's not part of the solution. Label it -6 7/10, and x is less than -6 7/10. We forgot to translate. X is less than -6 7/10. All right. Let's try some word problems now. So with word problems, again, we're going to set up our 3 boxes method. If you don't remember, the first box is for information we know, what we're going to find, and then our work. Maribel wants to rent a bike for the afternoon. If the initial fee is $10 plus $3 each hour, what is the greatest number of hours she can rent the bike if she has $25 to spend? I'm not sure why there's a D there. So we know there's a $10 initial fee. It's $3 each hour. And she has a total of $25. What's it asking us to find? Oops. The greatest number of hours, right? She can rent the bike. So greatest number of hours she can rent the bike. And since we don't know, we'll name that our variable h. H equals greatest number of hours she can rent the bike. Okay. So same as before, our total goes on one side. Our initial fee is not changing, so that's our constant. And we have to add on the cost per hour, and it's $3 per hour. So this is the cost per hour, and this is number of hours. The tricky part is to figure out what direction the inequality symbol goes. So she has $25. Can she spend less than $25? Yes. Can she spend equal to exactly $25? Yes. Could she spend more than $25? No, because she doesn't have more than $25. So the question is, does the inequality symbol go this way or this way? Well, we know that this expression, when we simplify it, has to be smaller or equal to, right, the $25. So which way would that be? This one. So here's our inequality. The 10 plus 3h is going to be less than or equal to 25. Go ahead and solve that inequality and see what you get for the value of h. Let's talk about B. Edgar rode a taxi that charges $5 to start plus 25 cents per mile. How far did he travel if he spent at most $17? So we have 25 cents per mile, $5 to start. That's like the initial fee. And he spent at most $17. If you don't remember what at most means, go back to the previous notes where it has that box at the top and it has some phrases and some inequality symbols there. What's it asking us to find? How far did he travel? So we're talking about miles. So we're going to call that M. M equals number of miles traveled. Okay, now your job, set up this inequality, then solve it. Great job. Time for some more practice. See you next time.